Hello everyone and welcome to this video illustration where I'll be showcasing a program that determines how many degrees of separations two actors are apart. So this is based on the 6 degrees of Kevin Bacon, where if I give the program two given actors like Emma and Jennifer, for example, it will tell me how many degrees of separation the two are apart, whereby each degree of separation is just a movie that two actors start in. So Emma and Brendan start in the Harry Potter movie, and then Brendan and Michael start in Trespass, and then Michael and Jennifer start in the X-Men movie, and so we've connected those two together. So for this problem, we're going to use an uninformed search, is specifically breadth first search. Since compared to its counterpart, depth first, it takes up more memory and more time, but it's guaranteed to find the most optimal path, which is what we want here. So if we jump into our code, specifically the function that finds in the short path, we'll see that we've defined an instance of the QFrontier class and an instances of the node class. So if we jump at their definition here, we'll see that the node holds three attributes: the state, which will represent in the person's ID, the parent, which is the person ID of the node that generated it, and the action, which is the movie ID. So here, for example, if this is my node, it will hold its own ID, the person's ID of the node that generated it, and the thing that connects those two is the movie ID, which is the action. As for our Q frontier, it inherits everything from the stack frontier. So if we focus here on the two attributes, we'll see that the two frontiers have a frontier list, which contains a list of all the nodes that we want to explore, and an explored list, which will hold the states that we have previously explored as to not go through them again, and a bunch of methods to interact with that frontier. But the one we'll focus on is the remove method, which removes the first node of the list, since the queue is first in first out. So the first node is the first one that was in. It will remove it and obviously add that state to the explored list and returning it. So if we jump back to the code here, we initiate our frontier, our Q frontier, and then add the parent. So here, as you can see, the parent will not have in the source node will not have any parents nor any actions that generated it, so both are none. And then while the frontier is not empty, so if the frontier is empty, we can conclude that we've exhausted all of the nodes and that there is no path to be found. So while the frontier is not empty, we'd remove a node and then pass it in and expand it. And if we find a solution, we would return it. Otherwise, we'll keep repeating the process. So our expand function here, it takes in the frontier, the source node, and the targeted state, and then generates a list or a tuple of all of the neighboring persons. So if I give it this node, for example, it will give me all those three nodes represented in a tuple. So movie ID, person ID, movie ID, person ID, movie ID, person ID in a tuple. And then we look, if the person ID is the targeted state, then we'll just get its path, which is the path from the source node to that targeted node, and return it as our solution. Otherwise, we check if we have this state. So if we don't have this state in our frontier and we've not explored it previously, we add it to our frontier so that we can expand it later. And so if I run the code here to show you a quick illustration. Okay, so once the database loads, we're loading here the large database. We'll be prompted for a name. So let's pick any name here at random, and hope we'll get more than 1 degree of separation. So let's go with this one, and let's take another one and pass it in. So we'll see here that if we look our Q frontier right here, we'll see that our explored list is empty, while our frontier has one node, which is the parent node. And then if we step in and remove the node, we'll see that its ID was moved to the explore, and now the frontier is empty. And then once we expand it, we'll see that we've added all of those nodes, and we can even check if we found a solution or not. So yeah, there was no solution, so the process will repeat again. We'll remove a node, we'll add more nodes, and then add the node that we removed to the explored state, and we'll keep repeating this process until we find a solution. And as you can see here, the program determines that there's 2 degrees of separation and prints them out to us. And we can do the same thing again using our small database. So here if I say python of degrees.py and then small, it will ask me for the name. I'll give it, and let's pick another one. Yeah, let's take this guy, and 1 degree of separation. So that's it for the illustration. Thank you so much for watching. Take care and have a nice day.